folks, welcome to another set of 8th grade science video notes. Today we're going to be talking about the types of matter. So there are 5 different things we're going to talk about when we talk about matter. We have atoms, elements, molecules, compounds, and mixtures. So the atom. If you'll remember, atoms are single particles that have protons, neutrons, and electrons. Atoms are the smallest particle that you can divide an element into and still have that element. Molecules, on the other hand, are combinations of atoms. Anytime you have 2 or more atoms stuck together, or chemically bonded, we say, you have a molecule. A molecule is the smallest particle that you can divide a substance into and still have that substance. If you break a molecule down into anything smaller than just the molecule, you end up with a bunch of atoms of different elements. And then it's no longer the substance that you started with. Up here you can see some pictures of molecules. The first one we have is O3. That's 3 oxygen atoms stuck together, also known as ozone if you're really curious. We also have H2O, which is water, 2 hydrogens and an oxygen stuck together. And we have NH3, which is 1 nitrogen and 3 hydrogens, also known as ammonia. The important thing to notice about all 3 of these examples are that you have more than 1 atom, and those atoms are stuck together. They can't move away from each other. They are bonded chemically to each other, and that's what makes them a molecule. Okay, so now we know that we can have atoms or molecules. Those are basically the 2 different types of matter that we can have. We could also classify matter by what they're made up of or how they're combined. So an element is 1 single atom of an element or 2 or more atoms of an element that are stuck together with chemical bonds. The important thing about an element is no matter how many you have, they're always going to be the same element. You don't have more than 1 different type of element there. A compound, on the other hand, has 2 or more different elements that are stuck together with chemical bonds. A mixture, however, is different because the pieces aren't necessarily stuck together. You could have some atoms, you could have some molecules, you could have some elements, you could have some compounds. As long as you have more than 1 different thing that isn't stuck to something else, you have a mixture. So let's look at some illustrations of these types of matter. I like to look at these in 2 different ways. We could use Legos to represent the different atoms we have, or we could just use circles that we draw on the page. So here for elements, notice we've got 2 Lego bricks stuck together. Both of those bricks are the same color, so you would assume this is the same element. And since you've got 2 stuck together and they're the same element, that would be a molecule that's considered an element. An example of that would be 2 oxygen atoms that are stuck together. Even though we have a molecule because we have more than 1 atom, it's still just an element because we only have 1 type of atom in our molecule. Next, if we look at a compound, here we have the Lego bricks. We've got 2 blues and 1 red all stuck together. Again, that's a molecule, but this time it's a compound because we have different colored Legos stuck together. This is a Lego representation of a water molecule. So the drawing here of a water molecule has 1 big oxygen atom with 2 little blue atoms that are hydrogen stuck together. And since they're all 3 stuck together, again, it's a molecule, but it's a compound because we have oxygen and hydrogen, and that's 2 different elements. Lastly, we have a mixture. Here, our picture has just a green Lego laying around. It's got 2 browns and a yellow that are stuck together, but they're not connected to the green. We've got another 2 blues and a red that are stuck together, but they're not connected to the other 2. It's just a mixture of different types of matter. The other picture that represents a mixture here is a whole bunch of green atoms floating around a whole bunch of purple 2-atomed molecules. Notice the green stuff and the purple stuff is different, but they're not connected together, so it's a mixture. One important thing to note is that elements and compounds are considered pure substances. That means 1, no matter how much you have, it's going to have the same density if you have that element or that compound. And 2, no matter what, it's always going to consist of the same exact stuff. So a compound of table salt, sodium chloride, NaCl, No matter what, it's always going to have one Na for every one Cl that it has. Any other combination of that no longer is table salt. And then it's a different type of substance. Okay, let's dig a little bit deeper. So we talked about elements. There's 3 ways to classify an element, which you've learned before. We have metals, nonmetals, and metalloids. Again, an element could be one atom of an element, or it could be more than one atom as long as they're stuck together. Some examples would be a chunk of copper, that's considered an element, or a sheet of aluminum foil, or a single atom of neon, 2 atoms of hydrogen stuck together, or 100 carbon atoms that are stuck together. As long as we only have one type of atom, or one type of element in our molecule. Compounds are classified by what it's made out of, so the different types of elements it has in it. And when we talk about the atoms of a compound, it consists of at least 2 atoms, and they have different elements in them. And the important thing is that these atoms are chemically bonded together, so they're stuck together, but there's different elements there, and that's what makes it a compound. Some examples would be water, which is over here at the top, sugar, which is in the middle, and dynamite, which is at the very bottom. All of these pictures have more than one atom, and they have more than one type of element. And all of those atoms are chemically bonded together, and that's what makes it a compound. So there's a few different ways we can name molecules. If the molecule is an element, so you have 2 atoms of hydrogen stuck together, we just call it hydrogen. And then if the molecule is a compound, there are certain procedures on how you name them based on what it's made out of. But we're just going to learn the simple way, or the shorthand way. So you learned that a chemical symbol represents an element, like H is hydrogen, He is helium. A chemical formula represents a molecule. Chemical formulas just take the chemical symbols of the different elements in the molecule, smushes them together, and puts a little subscript next to the chemical symbols that tell you how many atoms of that element are in the molecule. So our example here, which is pictured off to the right of this page, is water. A water molecule consists of 2 hydrogen atoms and 1 oxygen atom chemically bonded together. The chemical symbol for hydrogen is H, and the chemical symbol for oxygen is O. We have 2 hydrogens and 1 oxygen, so we call it H2O. Those little numbers to the right of the chemical symbol in a chemical formula are called subscripts. And here we have H2 because there are 2 H's, and then O. You might think, why isn't it H2O1? Well, that's a great question. Chemists are a little bit lazy sometimes, and we don't like to write 1s when we don't have to. The fact that we even wrote O there to begin with signifies that there's at least 1 atom of oxygen in an H2O molecule. Any more than that, we have to specify how many there are. But if we just have 1, we just put the O. We don't worry about writing a subscript next to it. All right, so let's practice with our chemical formulas a little bit. Here you see a picture of 1 carbon atom and 4 hydrogen atoms all chemically bonded together. This is a molecule of methane, which is a compound. To write the chemical formula, we count up how many atoms we have in the molecule. So we have 1 carbon atom and 4 hydrogen atoms. We call it CH4. Next, we have a molecule of acetic acid, that's vinegar. You notice there are 2 carbons, 2 oxygens, and 4 hydrogens, so we call it C2O2H4. Let's try it the other way now. If I give you the chemical formula, you have to be able to draw the molecule. So here we have CaCl2, that's calcium chloride. Remember, chemical symbols start with capital letters, so in a chemical formula, every time you hit a capital letter, that's a new element. So we have capital C, lowercase a, that's 1 element, Ca, calcium. There's only 1 atom of calcium, so we can go ahead and put the atom of calcium here. And then it's Cl2, that's 2 atoms of chlorine. So we put the 2 atoms of chlorine here, connect them all together because it's a compound, or a molecule, and now we have our picture of CaCl2. Finally, we have Mg3N2, that would be magnesium nitride. It says Mg3, that means there are 3 magnesiums, so we can go ahead and put 3 magnesiums down. And then it says N2, which means there are 2 nitrogens. So we put 2 nitrogens, and now we connect them all together because, again, it's a molecule or a compound. And now we have our picture of Mg3N2.